Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on linear time invariant systems using Laplace transform. Laplace transform represents continuous time signals in terms of complex exponential, that is nothing but e power minus st. Laplace transform can be used to analyze signals or functions which are not absolutely integrable. Continuous time signals can be also be analyzed effectively using Laplace transform. Laplace transform of impulse response is called as system function or transfer function. Laplace transform is divided into unilateral Laplace transform and bilateral Laplace transform. System transfer function, ratio of the output to the input, h of s is equal to y of s divided by x of s. Frequency response, h of omega is equal to y of omega divided by x of omega. When x of t is applied to your Fourier transform, we can get the output as x of omega. Again, for frequency domain analysis function, we can get the output as y of omega. While we taking the inverse Fourier transform of y of omega, we can get the output as y of t. Condition of a linear time invariant system to be causal is nothing but h of t is equal to 0 for t less than 0. Condition for a linear time invariant system to be stable, summation k is equal to minus infinite to plus infinite, modulus of h of k should be less than infinite. Impulse response is the output generated by the system when an unit impulse is applied at the input. When x of t is applied to your linear time invariant system, which can produce the output as y of t, which is equal to x of t. H of s is equal to y of s divided by x of s. While how to find the impulse response of the system, while we taking the Fourier transform of system transfer function is nothing but h of t. H of t is equal to Laplace inverse of h of s. Del of t function can be defined as 1 for t is equal to 0, 0 for t should be not equal to 0. Time domain into frequency domain, where x of t can be applied to your h of t, which can produce the output as y of t is equal to h of t into x of t. While we taking the Laplace transform of h of t, which can produce the output as h of x of s. For h of t, h of s. Output y of t, which is equal to h of t into x of t. While we are applying Laplace transform, we can get y of s is equal to h of s into x of s. While we are applying inverse transform, we can get y of t is equal to h of t into x of t. This is the time domain into frequency domain representation. Next, another for linear differential equation, we can apply the time domain solution. For applying Laplace transform, we can get the Laplace transformed equation. For that, we can find out the algebraic equation, we can find the Laplace solution. While we are applying the inverse Laplace transform, we can getting the time domain function. This is the sequence of the Laplace transform. How to find the impulse response? First, we can find the differential equation. We can apply the Laplace transform, and then for algebraic, we can taking the algebraic equation, solving for roots, and for that impulse response function, for that system transfer function, we can applying the inverse Laplace transform. We can getting the impulse response of the system. Basic signals, unit step signal, it has an 1 for t greater than or equal to 0, 0 for t less than 0. Del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. Unit ramp function can be defined as t for t greater than or equal to 0, 0 for t less than 0. This is the graphical representation of unit step, unit impulse and unit ramp function. How to find the Laplace transform of unit step function? X of f is equal to integral over minus infinite to plus infinite x of t into e power minus st into dt. We can get e power minus st divided by minus s. Applying integral over 0 to infinite, we can get x of s is equal to 1 by s. For unit ramp signal, t into u of t. T into r of t into u of t, we can apply the uv method. We can get the results as x of s is equal to 1 by s square. Find the output of the system. H of t is equal to u of t. X of t is equal to e power minus 2t into u of t. H of s is equal to 1 by s. X of s is equal to 1 by s plus 2. Therefore, h of s is equal to y of s divided by output x of s. Therefore, y of s is equal to h of s into x of s. 1 by s into s plus 2. Therefore, a by s plus b by s plus 2. we can find out the a as 1 by 2, b as minus 1 by 2, y of s is equal to 1 by 2 into s minus 1 by 2 into 1 divided by s plus 2. While can apply the inverse Laplace transform of y of s function, we can get the output as y of t is equal to 1 by 2 into u of t minus 1 by 2 into e power minus 2t into u of t. Next, RC into d by dt into y of t plus y of t, which is equal to x of t. Find the impulse response of the system. RC into d by dt is replaced as s y of s plus y of s, which is equal to x of s. Therefore, x of s is equal to h of s is equal to y of s divided by x of s, which is equal to 1 divided by RC into s plus 1. While we are applying the inverse Laplace transform of 1 by RC into s plus 1, we can get h of t is equal to 1 by RC into e power minus t into u of t. Next one, to find the impulse response of the system, d square divided by dt square into y of t minus d by dt into y of t minus 2 into y of t, which is equal to x of t. While we are applying the Laplace transform of above function, s square into y of s minus s into y of s, which is minus 2 into y of s, which is equal to x of s. Therefore, y of s divided by x of s is equal to 1 divided by s square minus s minus 2. 1 divided by s minus 2 into s plus 1. We can s is equal to minus 1, b is equal to minus 1 by t. Substitute s is equal to 2, a is equal to 1 by 3. h of s is equal to 1 by 3 into s minus 2 minus 1 by 3 into s plus 1. While we are applying the inverse Laplace of above function, we can get h of t is equal to 1 by 3 into e power 2t into u of t minus 1 by t into e power minus t into u of t. Next one, Laplace transform results, e power minus t into u of t, which is equal to 1 divided by s plus 1. Real of s should be greater than minus 1. Minus e power minus 2t into u of t, while applying Laplace transform, minus of 1 divided by s plus 2, real of s should be greater than minus 2. E power minus t into u of t minus of e power minus 2t into u of t, while we are applying the Laplace transform, 1 divided by s plus 1 minus of 1 divided by s plus 2, real of s should be greater than minus 1. E power minus t into u of t minus of e power minus 2t into u of t, Laplace 1 divided by s plus 1 into s plus 2, real of s should be greater than minus 1. Shifting property, unilateral Laplace transform with initial conditions. Laplace transform of d by dt into x of t is equal to s into x of s minus x of 0 minus. Laplace transform of d square divided by dt square into x of t is equal to s square into x of s minus x of 0 minus minus x dash of 0 minus. While we are applying the d square divided by dt square into x of t, s cube into x of s minus s square of x of 0 minus minus s into x dash of 0 minus minus x double dash of 0 minus. Solving using differential equations with initial conditions, d by dt into y of t plus 5 into y of t, which is equal to x of t, with initial condition y of 0 minus is equal to minus 2 and input x of t is equal to 3 into e power minus 2t into u of t. While we are applying the above equation, s into y of s minus y of 0 minus plus 5 into y of s, which is equal to x of s. Y of 0 minus can be given as minus 2, minus into minus plus. Y of s we can take as common, s plus 5 plus 2, which is equal to 3 divided by s plus 2. Y of s into s plus 5, which is equal to 3 by s plus 2 minus 2. Therefore, y of s is equal to 3 divided by s plus 2 into s plus 5 minus 2 divided by s plus 5. Then solving for roots, we can get s is equal to minus 5, b is equal to minus 1, s is equal to minus 1, a is equal to 1. Therefore, y of s is equal to 1 divided by s plus 2 minus 1 divided by s plus 5 minus 2 divided by s plus 5. Therefore, y of s is equal to 1 divided by s plus 2 minus 1 minus 2, which is added, minus 3 divided by s plus 5. While we are applying the inverse Laplace transform, y of t is equal to e power minus 2t into u of t minus 3 into e power minus 5t into u of t. Next one, the input-output relation of a system at initial rest is given by d square divided by dt square into y of t plus 4 into d by dt into y of t plus 3 into y of t, which is equal to d by dt into x of t plus 2 into x of t. Find the system transfer function. While we are applying the Laplace transform of above function, s into s square into y of s plus 4 into s into y of s plus 3 into y of s, which is equal to s into x of s plus 2 into x of s. While we taking y of s as common, x of s as common, therefore h of s is equal to y of s divided by x of s, which is equal to s plus 2 divided by s square plus 4s plus 3. How to find the frequency response? S can be replaced by j omega, which is equal to frequency response of the system. Next one, at initial test is given by d square divided by dt square into y of t plus 4 into d by dt into y of t plus 3 into y of t, which is equal to d by dt into x of t plus 2 into x of t. H of s is equal to s plus 2 divided by s square plus 4s plus 3. Now we can substitute a divided by s plus 3, b divided by s plus 1. S is equal to minus 1, b is equal to 1 by 2, s is equal to minus 3, a is equal to 1 by 2. Therefore, h of s is equal to 1 by 2 into s plus 3 plus 1 by 2 into s plus 1. While we are applying the inverse Laplace of above function, we can get h of t, which is equal to 1 by 2 into e power minus 3t into e of t plus 1 by 2 into e power minus t into e of t. Now we can see the assessment. What is mean by impulse response? When the impulse response can be applied to your linear time invariant CT system, which can produce the output as h of t, that is nothing but impulse response of the system. Define unit step and unit impulse function. Unit step can be defined as u of t is equal to 1 for t greater than or equal to 0, 0 for t less than 0. Unit impulse del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. The condition of an LTI system to be causal is given by h of t is equal to 0 for t greater than 0. The system transfer function is given by h of s is equal to y of s divided by x of s. Laplace transform of unit step function is given by x of s is equal to 1 by s. Laplace transform of unit function is given by x of s is equal to 1 divided by s square. Thank you.